Barry Allen, aka The Flash, is the fastest man alive, who has the ability to tap into the Speed Force, which allows him unlimited speed. The Flash is a member of the DC Comics universe who has the ability to travel at speeds exceeding that of light, and uses this to fight crime and keep the peace within Central City. So join us as we jump in and take a look at the physics of the Flash. Let's find the time it would take the Flash to run around the Earth at the speed of light compared to an average man running at the speed of 12.5 meters per second. We need to know the radius of the Earth, which is around 40 million meters. To do this, we simply need the equation t equals d over v. For the Flash, this will give him a time of 0.1335 seconds, but for the average man, this will give him around 37.1 days. This is a difference of over 24 million. Next, let's find the centripetal force of the Flash as he runs around the Earth. We know the mass of the Flash, the speed of the Flash, moving at 3,402.9 meters per second, and the radius of the Earth. To do this, we need the formula Fc equals mv squared over r. First, we're going to multiply our mass by our velocity, and square our velocity, and divide this by the radius. This will give you a centripetal force of 159 newtons. Next, let's find the period it takes the Flash to run around the Earth one time. We're going to use the same velocity and radius as before, and we're going to take these values and sub it into equation t equals 2 pi r over v. This will give you a value of 3.26 hours.
Now let's take a look at the energy and momentum in relation to the Flash. Flash's nemesis, Captain Colt, is robbing a bank. If the Flash runs at a speed of Mach 3, which is 1,020 meters per second, and punches Captain Colt, who is standing still, what will their velocities be if the Flash weighs 88 kilograms and Colt 89 kilograms? For this problem, you are given both masses and velocities, 88 kilograms for the Flash and 89 kilograms for Captain Colt, 1,020 meters per second for the Flash, and 0 meters per second for Captain Colt. For this problem, we'll be using the equation Vf1 is equal to m1 minus m2 times Vi1 plus 2 times m2 Vi2 all over m1 plus m2 for the Flash's final velocity. After plugging in all the values and solving, we will derive to an answer of negative 5.76 meters per second. This value is negative because the Flash travels backwards after punching Captain Colt. To calculate Captain Colt's speed, we'll be using the same values, but this time we'll be using the equation 2m1 vi1 minus, in brackets, m1 minus m2 times vi2 all over m1 plus m2. Once again, after plugging in all the values, we will derive to an answer of 1,014.23 meters per second. Now that we have Colt's final velocity, we can calculate momentum using the equation P is equal to mv. Plugging in the mass of 89 kilograms and multiplying it by the velocity of 1,014.23 meters per second, we'll get an answer of 90,266.43 kilograms per meter second. Now calculating the kinetic energy, using the equation 1/2 mv squared, we will plug the same values in and get an answer of 45,775,480.93